Hello children, let's summarize whatever we have learned till now. This is a velocity time graph of two objects, object 1 and object 2, right? So let's look at it a little bit more in detail. Object 2 starts from 0, the velocity is 0 at time 0. The velocity goes on increasing, right? It comes up to at 4 seconds, it has reached a velocity of 8 meters per second. And then it remains at a constant velocity of 8 meters per second. And then till the 7th second, right? Till the 7th second. And then the velocity goes on decreasing. It reaches, again it comes down to 0 in the 10th second. Yeah. So now, what do we notice in this? We notice that when the velocity is constant, that is from the 4th second till the 7th second, the velocity is not increasing, it's a constant velocity. And this constant velocity means what? The acceleration is 0. During this time, the velocity line graph, time graph is a straight horizontal line. So that's what the first point we should notice in a velocity time graph. Horizontal lines indicate that the velocity is constant or that there is 0 acceleration. Correct? Yeah. Now let's look at the initial part of the graph, right? So when the velocity of the object starts increasing from 0, it goes up to 8. Correct. If you notice, every second, equal intervals of time from 0 to the first second, the velocity has come to 2. In the second interval, first second to the second second, the velocity has reached 4. So which means every second the velocity is increasing by 2 meters per second, right? So this is a constant increase in velocity, or in other words, this is what we call as constant acceleration. And this comes out to be a straight line, as you can see in a velocity time graph. So that's the second important point that we should note, in the sense that straight lines in a velocity time graph, the straight lines indicate that the velocity is increasing or decreasing at a constant rate. That is, the acceleration or the deceleration is a constant value. Correct? Okay. And then just now look at the object, the blue object, right? The blue object, that is object 1, starts at a velocity of 0 meters per second. At 2 seconds itself, it has reached a velocity of 10 meters per second. Correct? Which means that the acceleration is, in 2 seconds, it has reached 10 meters per second, and its acceleration is going to be, so the acceleration is going to be, the formula for the acceleration is final velocity minus the initial velocity by the time taken, which is 10 meters minus 0 meters per second by 2. So we get a acceleration of 5 meters per second squared for object 1. The same thing, look at object 2, right? So what is happening in object 2? In 0 to 4 seconds, the first time interval, the velocity increases from 0 to 8 meters per second. So in other words, the acceleration is 8, the final velocity, minus 0, the initial velocity, divided by the time interval, that is 4, that is 2 meters per second square. So if you compare in the velocity time graph, if you compare the graph of the object 2 with the object 1, we see that the object 1's line is steeper. So that is what we can understand from a velocity time graph, that is, a steeper line, right, indicates that the higher acceleration, the blue object has got a greater acceleration and hence travels faster than the red line. So you look at, if the line is steeper, then it means that particular object has got a higher acceleration. So let's look at one more very important idea or a concept that we can learn from a velocity time graph, and that is the area under the velocity time graph gives the total distance traveled. Correct? So if we look at a velocity time graph, here we call it as it's shown as a speed versus time, but then here, since we are assuming the object is traveling in straight lines, so the direction is constant, the speed and velocity, the terms can be used interchangeably because we are looking at only the magnitudes right here. So here this particular object starts at a velocity of 0 meters per second. It goes up to a velocity of 15 meters per second in 10 seconds, and then it remains at 15 meters per second till the 20th second. It again starts to increase, the velocity increases, it reaches 25 meters per second at the 30th second, and then it starts to come down. It is a certain deceleration happens, right? It comes down up till 0. It again comes to rest at the 50th second. Correct? Now, this particular velocity time graph, it has a particular shape, right? Now, the area under this, inside this shape, is what that is going to give you the total distance traveled. So how do you find the area under this funny shape? We can divide it into different parts, okay, and whose areas we can calculate. So here we have a triangle and here we have a rectangle. So we have divided it into different parts like A, B, C, D and E and each of these, they have a particular shape for which we have a formula to determine the area, right? So the area of this entire shape is the sum of the areas of the shapes A, B, C, D and E. So here we are trying to calculate the areas. So what is the area of the shape A? That is a triangle. So we have it is half base into height. So half into 10 on the x-axis, that is the base, and the height is going to be 15, right? So half into 10 into 15, and that gives you 75. So what is the area of shape B? That is a rectangle. Shape B is a rectangle. So what is an area of a rectangle? We know it is length into breadth. So 10 is the length, we can say, and the breadth is going to be 15. So totally it is going to be 150 meters. So on and so forth. You calculate the area of all the individual shapes, and then we get a total area is 675, and since this represents a distance traveled, we give it a unit of meters to show that it's the distance traveled. Fine. So, and then one more thing, if you want to find the distance traveled in a particular time interval, say between 20 and 30, correct? In this time interval, you want to know what is the distance traveled by the object. So for that, we have to calculate the area in this particular time interval under this particular graph, right? So that is the area of C and E together, right? So C plus E together will give you the distance traveled in this particular time interval. So remember children, when we have a velocity time graph, the area under that graph gives you the distance traveled, and this distance we can calculate by dividing it into different shapes for which we can calculate the area, like triangles and squares. So here is a brief comparison of the distance time graph and a velocity time graph, right? So you learnt about distance time graph in the previous class, and in this class you learnt about velocity time graphs here. So here is a brief comparison. So distance here is represented by s on the y-axis, and we have t on the x-axis. And the velocity time graph, we have velocity v on the y-axis and t, the time taken on the x-axis. Correct? So now, if the object is stationary, right? How does a distance time graph look? Because it's stationary, it is at a specific location, which is at a specific distance from the reference point. So this specific location does not change because the object is stationary. It's at the same point. So as the time progresses, the object is at the same point. So we get a horizontal line in a distance time graph. Same thing in a velocity time graph. Since the velocity is 0, the object is stationary, right? The velocity is 0. So in a velocity time graph, it will be along the x-axis itself, right? Because of 0 velocity, as time progresses, it's the same thing as the x-axis. Now look at how the graph is going to look when the object is moving with a constant velocity. In a distance time graph, since the object is moving at a constant velocity, the distance from the reference point is going to go on increasing. So it is going to travel forward. It is going to travel equal distances in equal time intervals, right? Because the velocity is a constant. So at equal time, 1, 2, 3 seconds, etc., it's going to travel equal time distances. So this graph is a straight line in a distance time graph. But in a velocity time graph, the velocity is a constant velocity. So it is over here some velocity v, and over the time, as the time increases, the velocity remains constant. So it is just a flat horizontal line. So this is how an object traveling with a constant velocity is going to look in a velocity time graph. Suppose in a distance time graph, if we want to show how does the object look if it has a constant acceleration, means the velocity is going to keep on increasing. It's not a constant velocity, means different distances is going to be covered in different time intervals. As the time goes on increasing, right, in time, greater and greater amounts of distances are going to be covered because the velocity is increasing. So this graph is a curve, right? The distance time graph looks like a curve when we have a constant acceleration. But the same thing, a velocity time graph, since the velocity is increasing, but it's increasing at the constant rate, right? It's a constant, acceleration is constant, right? So the velocity time graph is a straight line, right? The velocity increases at constant rates in constant time intervals. So this is a straight line. Yeah. Thank you.